Good morning. I'm going to go back over the data and the analysis for 1.4 relating mass and volume lab. Yesterday, we went into lab and we collected this data right here, right? And I sent you that in the chat. You had to figure out the volume of the metal, right? So taking the volume of the water plus the metal and subtracting it from just the volume of the water gives you the volume of the metal. I then used Excel to quickly graph the volume and mass of those metal samples. In graphing those 6 data points, I could see clusters, right, knowing that there were 2 types of metals, a dark steely gray versus a light aluminum kind of gray, silver color, that we had these 2 different types of metals. And then I graphed those with the data points. I then made lines of best fit on Excel, right? They're called trend lines. Those trend lines need to go through the origin so that there's no intercept, or y equals mx plus b is the equation of a linear line, but we don't want a b here. We want it to go through the origin, because if there's no mass, there should be no volume. And then we talked about how the slope of that line was something you needed to calculate. From your slope, what does that mean, right? So because our numbers have meaning in science, we graphed mass over volume. So our rise is mass and our run is volume. So since slope is rise over run, our slope is mass over volume, which is called density, right? So these slopes, these m's that are here in my linear equation, those are the densities of those substances. In graphing those densities, I now know, right, that I can take a volume of, let's say, those little beads that were light and figure out what mass they should be. A lot of people were very confused by part 3, right? So in part 3, we did the water displacement of the beads that were light. Because they were light, you would want to use the one that has less density, okay? The least dense, the one that has a lower slope, right? Knowing what that volume was, you would come up to the line and then read over what the mass should have been based on your graph, okay? Or if you're more of a math person, you could use your slope as your density and then just solve. Knowing the volume and the density, you can find the mass using the formula density is mass divided by volume. Either way will work, okay? Then later yesterday, I sent you the actual mass of those beads. They're aluminum beads. And so with that aluminum, you should be able to get a percent error of your graph. How good was your graph, right? That's basically the question. So based on the volume, you could find the mass from your graph. That's your experimental value. Then I sent you the actual value of the mass in the remind text as a picture of the scale, right? And so you should be able to calculate a percent error from there. I hope that helps answer any questions you have about the 1.4 lab. See you later.